everyone for coming today. I have a super exciting talk, and that talk is Web for All, the power of progressive web applications. Before I begin, I'm gonna introduce myself. I'm a senior developer advocate for a company called OneSignal. I'm also a member of the Google Developer Experts Program for Angular and Web Technologies, Auth0 Ambassador, Google Woman Tech Maker, Twilio Champ, Media Developer Expert, AWS Community Builder, and a Postman Casanova. But I'm not really gonna be talking about me. This talk is about PWAs. So why don't we go ahead and start defining what is a PWA? Well, PWA stands for Progressive Web Applications. PWAs are web applications that have the ability to be installed on your device like a native application. The way I see PWAs is the following way. They're regular web applications, but with superpowers. So, what are some of the superpowers of PWAs? PWAs have different superpowers. Some of them are installability, which means you can install a PWA in your device, right? They're SEO friendly, they're push notifications friendly, they load pretty fast in your application, right? They provide that great user experience because they are responsive, right? So you're gonna have that feeling that you are interacting with a regular native application. They provide the offline experience, something that native applications do not provide. They process payments, and they're multi-platform, meaning that with just web, you can have a PWA installed in your iPad, in your iPhone, in your Android device, in your Mac, you name it, PWA is for all. They're secure, right? They only work through HTTPS, and they provide caching strategies. Sadly, not everything is perfect with PWAs. I know, guys. I'm pretty sad as well for that. So, some of the disadvantages of PWAs mean they have less access to system features than a native app, right? Every year, the web keeps growing and keeps getting better. So every year we have more functionalities for your device thanks to the web. There's another project called Project Fugu that is enabling most of the features and characteristics of your mobile devices in the web, right? So keep that in mind. Another problem is that there's not such a review standard, right? For example, if you create a native application and you put it in the App Store, right? Someone is gonna review it. Someone has to approve that App Store. The same for, doesn't matter if it's the one for Apple or the one for Google. Someone has to review that application. In the web, it's free game. You put it online, it's live, anyone can access it, right? So it's the same with PWA. It's the same process. If you know how to publish a regular website, you know how to publish a PWA. Now, another problem that we're having is that Apple needs to catch up with tech, right? Yes, Apple supports PWAs, but not all the features or all the superpowers that PWAs are offering you are available in Apple devices. So keep that in mind. So now in this talk, right, I'm also gonna tell you how I grew a business with PWAs and how I was able to accomplish having the web for all, right, to all the customers of this company that I did consulting for. A few of the problems that the company that I was working for had was that it was located all over the world, right? Which actually that's a good thing. But the problem was that in a lot of the places where this company was located, they have really bad internet connection. So that's one problem. The second problem is a high operational cost to have an app, because money, and we help them with that as well. And the last problem that they had was that they were trying to find a way to create brand awareness for their application and grow their business. So let's talk about the first problem, the bad internet connection. We were able to tackle this problem in two different ways, using service workers and using the background sync API. So service workers and background sync API to the rescue. Let's talk about first about service workers. So service workers are awesome. From my personal point of view, service workers are the muscles of E2As. Service workers do the heavy lifting, right? Service workers are amazing. I'm obsessed with them, as you can tell. I'm already excited. You can see on my pages to talk about service workers. And service workers make your app work offline, right? So I got kicked out of the screen. Give me a second. Hi everyone. Sorry, I noticed that I was on mute. If I'm not mistaken, can someone tell me if that was the case? Hopefully, I wasn't. If I was, I apologize. I'm going to be talking about the web for all, the power of progressive web applications. Sorry for the technical difficulties. I'm a senior developer advocate for OneSignal. I'm a member of the Google Developer Expert Program on Angular Web Technologies. I'm a Tool Champion, of the Zero Ambassador, Spring Boot Mentor, AWS Community Builder, and so on. So before I begin, I need to define what a PWA is, right? A PWA stands for Progressive Web Applications. PWAs are web applications that have the ability to be installed on your device like a native application. So essentially, there are web applications with superpowers that are going to take your web application to the next level. So you might be wondering, well, that sounds great. What are some of the superpowers of progressive web applications, right? So some of the superpowers, it feels so weird that I'm repeating the same just because of the technical difficulties. But the PWAs have the superpower of being installed, right? They are SEO friendly. They are friendly with push notifications. They fast load, right? They have great user experience. Why? Because your application is going to be mobile friendly. They provide offline experience as well. They do payment processing. They're multi-platform, right? Meaning that you can install your progressive web application on your mobile device. Doesn't matter if it's Android, Apple, it can be on your Mac, on your Windows machine. They're also very secure. They are served through HTTPS, and they provide caching strategies. So like I was saying, once again, the disadvantage of the PWAs are three that I have seen, which is sad. I mean, not everything is perfect with PWAs, but they're getting better. They have less access to system features than a native app, right? The cool thing about this, about the web overall, is like it moves really fast. So right now you may have limited access to the system features, right? But pretty soon, I don't see it too far. You're gonna have access to almost all the system features that a native application can provide, right? There's not such a review standard, meaning that you can publish anything on the web, right? So there's not anyone approving your website or rejecting your website saying, oh, we don't like your website. You know what? You need to make it better. There's no such a thing, right? So the same way you publish a web application is the same way you publish a PWA. You don't have to go through an app store. You don't have to go to Google Play or the App Store for Apple in order to get people using your application. So that's great. Also, Apple needs to catch up with tech, right? Sadly, Apple, they don't do the best at catching up with tech. They don't support a lot of the features provided by PWAs. They're trying to get better on that, but sadly, they haven't catch up compared to other browsers like Edge or Google Chrome. So now I'm going to tell you how I help a company grow their business with PWAs by making the web available for all their customers. So before we jump into the technical aspects, we need to define the problems. The company is located worldwide in several places. Where the company is located in those places, a lot of those places are in third world countries or developing countries, so they don't have a great internet connection. So that's the first problem. It's great that they are in multiple countries, but the problem is that they are depending on functioning a business via internet, and the internet is bad, right? Having an application at a huge scale can be very pricey, right? So they had a high operational cost because they had an Android app, they have an iOS app, and they had the web app, right? And then the company needed to find a way to grow their business and create awareness. And we solve all these problems with PWAs, with the superpowers. So let's talk about the first problem, the bad internet connection. This problem was solved using two of the superpowers of PWAs. The first superpower is service workers, and the second one is the background sync API. These superpowers to the rescue. So let's talk about the service workers. The service workers, they're amazing. I love them. I think they're super cool. They provide the muscles to the PWAs, right? They're the thing that lifts up the heavy weights. Service workers make your application available offline, right? And they provide caching strategies. If you don't have a service worker, you don't have a PWA. Also, thanks to the service workers, you get the push notifications working. So as you can see in this map, right? This is the map where the customer that I was working for, they were expanded, right? They were expanded all over the US, South America, Asia, Europe. I mean, oh my God, it's a huge company, right? But as you can see, most of the companies where they are located, they are in developing countries, right? And like I was saying, a lot of these countries, they don't have great internet connection. So thanks to the service workers, we make the PWAs that we made for the customer work offline, right? And we provide the caching strategies to make the loading experience of the web applications faster, right? So the web applications were loading way quicker, and the quicker they were loading, the better user experience people were having. The other superpower that helped with the bad internet connection was the background sync API. The background sync API is super interesting because it allows us to interact with a web application the same way as we were interacting with a web application if we were online. So if you're offline, you can do the same as you do online. Now you might be wondering, okay, that sounds great, but how exactly it works? Like, what does it do? So essentially what it does, right? Let's pretend that you have a store, right? The store, right? You're gonna see the items that you wanna buy. Let's say you want to buy some shoes, and that's amazing. The problem is that if you don't have internet connection, well, you're not gonna be able to buy a pair of shoes. But thanks to the background sync API, this was possible. And the way it was possible is because we provided this API, right, which is actually native for the web. We provided this API to our client, and they realized they could use it the following way. So what they did is they integrated this API, and if I wanted to buy a pair of shoes and I didn't have internet connection, that was fine. So what happened is I purchased my pair of shoes, and once it was purchased, right, and I was offline, the call was cached, right? So the background sync API detected when your mobile device or any device that you were using with a PWA was online again, and sent the request to the servers, and then process the payments, and then send you maybe an email letting you know that that your purchase has been processed. So that's the way it works. That's the potential of it. The other thing that we tackled was growing the brand awareness, right? We tackled that via SEO and push notifications. So the cool thing about PWAs is that they are SEO friendly, which is awesome, right? So if you implement SEO in a regular web app, it's the same way you implement SEO in a PWA. This is an advantage compared to native applications because native applications do not have that ability to be searched by search engines, right? If you want to search for them, you need to either have another website that talks about them, right? Or you have to go to the App Store and look for them. So the cool thing about SEO is that it gives the customer the ability to have their items that they were selling in the search engines. So more people were able to find the products, more people were able to find the website, which means that they increase the sales. The other thing was the push notifications. Like I was telling you, the push notifications are accessible to your PWAs thanks to the service workers. If you don't have a service worker, you don't have a PWA. And if you don't have a service worker, you don't get push notifications. The cool thing about push notifications is that they help you engage with your customers, right? They also allow you to target your customers and provide a personalized experience. And of course, they allow you to notify your customers. So for example, right here, as you can see on the screen, there's a push notification and it says my name, hi Pato. So just by having my name, it's already creating a personalized experience. So instead of saying hi Pato, it can say hi everyone, or it can say whatever name of the customer you have on the list that is going to get a push notification. The cool thing about targeting customer is that you can target them, for example, by location, even by name, by gender, you name it, even by device. If let's say if they are using a Android device and you only want to target the Android devices, then you can do it. So everyone that has an Android device is going to get a push notification, or everyone that has a an Apple device is going to get a push notification. The cool thing about this, about push notifications, is that you can create a personalized experience and you can take your customers to specific places that they were interested on, right? For example, if they were subscribing to, let's say, women's clothes, right? You can send a push notification to only customers that subscribe to women's clothes and put a link. As you can see, well, you cannot really see it, but it says click here. You click on the push notification and it's going to redirect your users to a specific part of your web application, or PWA. The other problem that we were tackling is a high operational cost. So, whenever you have a web application, could be fairly cheap compared to having an Android and an iOS application, right? The problem with having applications in the market is that you may need a web app, an Android app, an iOS app. That costs money, right? So either you have multiple developers and those developers are divided by the web developers, mobile developers, Android and iOS developers, or you can tackle this problem by having a PWA. So essentially you have one type of developers, web developers, right? And they create your progressive web application and it's gonna work on Android and iOS devices as well. So you don't have to worry about having all these developers for multiple platforms, right? And you don't have to worry about someone approving your application, like I was telling you before. You finish your web app, you publish it, you're ready to go. The other thing that that we did to tackle the high operational cost was that all the calls to the API and they were using the server, but these calls, right, they could be cached, right? So if you could cache the calls, then you were paying less money on the server usage, right? Think about this. This company has millions of users worldwide, right? So imagine each user going to the application and using it, loading, let's say, the products that they were selling, and that involved multiple calls to the servers, to your backend, right? So essentially every time they get into the website, maybe they change to a different page to see different products, they were making calls. So we were able to accomplish reducing the high operational cost thanks to service workers and caching strategies. So now let's talk about the result. Like, okay, that sounds good. That sounds great with all the superpowers that we used to grow this company. But now tell me about the results. Now, while the company is now in over 120 countries, the majority of them are in third world countries and developing countries. 1 out of 5 Americans have products from the client that I work for, which is insane. Most likely I have like products from them in my house. We reduced the number of server calls by 32%. We increased the number of users by millions. Now they have millions of users using the progressive web application. We increase the user experience, right? Because if your application is loading faster and people have access to the progressive web app, if people have access to searching your items online, all these things help to increase the user experience, right? By 2019, the company was making over $8.8 billion in sales. The P2A first time load was a little bit over 3 seconds, which is great. That's amazing. And 63% of the households in Beijing, China, own at least one product of the customer that I work for. And the 50 and similar scenario, but in South Korea, 50% of the population has a product from my customer. So you might be wondering, well, is the P2A concept still like beta? Is it like something that people are testing? No, P2As are here to stay. P2As are growing. Companies are investing millions of dollars to make P2As better. Google, Microsoft, and Samsung are some of those companies that they want to make P2As better. So there's this awesome website called P2A Stats, right? It's a website where you can see some of the companies that use P2As. For example, Tinder. Tinder uses P2As. So if you find your true love using Tinder, well, thank it to P2As, right? Pinterest uses P2As as well. Flipkart, which is a similar website to Amazon. It's an e-commerce website in India. They use P2As. Let's go to page number 1. And I click on one of the test case studies. Starbucks uses P2As as well. So you see, P2As is not any concept. P2As are here to stay. P2As are ready for you to apply them to your business, right, and make it grow. So with that being said, now what I'm gonna do is I'm gonna show you how to build a tiny P2A. So the P2A that I'm gonna show you is this awesome P2A that I built right here. Obviously, like super simple. I have a few items, some Nike shoes. If you're liking my talk, make sure that you buy me a pair. And well, awesome. So like I was telling you, P2A consists in different components, right? One of them is the app manifest. The app manifest, it needs to be named manifest.json, right? And this manifest is gonna contain the theme color of your app and web app whenever, well, actually your progressive web app, whenever you install it in a device, right? It's gonna have the background color, it's gonna have the icon that is going to appear on your device once you install it. So as you can see, I have this guy right here. And another cool thing is that, for example, if I click in this icon, this gives me the ability to install this application in my computer. I'm using a Mac, so I have the ability to install it. Here's the name. I just call it my P2As, and this is the icon that I'm seeing in my manifest. So this is the icon that is going to be set on your device like any other icon that you see for another application. So another huge component that I was telling you is the service workers, right? Thanks to DevTools, you're able to see the lifecycle of the service workers that I'm going to be talking about the lifecycle in a few seconds. But yeah, you can see that it's activated and running, right? You can see that I have the cache right here. So if I go over here, I can see all the files that I have cached. I have a Nike shoe right here, which is this one right here is cached. I have my index.js file, my HTML, the icon, the CSS. Perfect. So now let's go back to service workers. I'm going to click offline and I'm going to refresh the page. Wait, hold on. My application is broken, right? And I'm going to tell you why, and I'm going to show you how to solve it and what is a common problem with people caching their assets. So as you could see, there's only one of them cached, right? So if I go to my cache storage right here, I can see all the items that have been cached. And as you can see, there's only one being cached, right? So that's the first problem, meaning that I need to go back to my application, do some modifications in order for me to cache all the assets. So whenever someone uses my application offline, they have access to the application like if they were online, right? So I'm gonna go back to service workers and I'm gonna click this again. Now I'm gonna be back online. Perfect. Now let's take a look to the code. Awesome. So like I was telling you, right, this is the actual code of this small PWA that I built. This is the manifest.json, right? This contains like the theme and the icon that I was telling you about that your PWA is going to use. So here's the name, here's the assets of the icons. It really depends which icon is going to use depending on the size of the screen and the device. Let's say if you use a iPhone, it's not going to be the same size of an icon for let's say for your computer, right? PWAs use a sitemap as well, right? Like any other website, they have this robot file as well. You can generate it. I'm just gonna move this from the screen. You can generate this robots file using this tool. That's just gonna help you with Google and crawling and all that. And here's my index.js file. So now let's talk about the lifecycle from the service worker, like I was telling you. The first thing that you have to do in order to register a service worker is to make sure that your browser supports the service worker, the navigator, right? So in this case, as you can see, if service worker exists in navigator, you know, if it's friendly with it, go ahead and register my service worker. My service worker is this file right here, which you can see it on the left side. And I'm actually gonna zoom in for you to see better. So here's my service worker. It's common practice to locate your service worker in the root of your project. So keep that in mind. So now let's pretend that my service worker has been registered. Now what's next? We're gonna go to the service worker right here, right? And I'm gonna scroll all the way up. And as you can see, here's the name of my cache, right? I named it my PWA shell v1, right? If I go back to my my application right here, you can see this is the name of my cache, right? And you can see these are all the other assets that I didn't cache. So let's uncomment that. We want to cache them, right? And I'm gonna continue with the lifecycle. So one of the life cycles is the install lifecycle. So essentially what happens is whenever you have a PWA, it's going to open the cache, right? And it's going to be using this name to name the cache. And then you have to pass the items, the assets, the files, and wherever you want to cache, you have to pass it to your cache. So as you can see, files to cache is this array right here. So now I'm telling my PWA, hey, I want you to cache all these assets. And then this code right here is super interesting because what it's doing is the following. So whenever you load your website, right, whether it's offline or online, it's gonna look for the items if they have been cached. If they have been cached, depending per request, right? So you know, every time that you want to load a web application or a website, and let's say every image, every file, it's an actual request to the server. Right, so it finds that request, looks for that specific file that you're trying to cache in the cache, and if it exists, then it's gonna return that resource, right? And if it doesn't, then it's gonna actually try to make the fetch call to the server and get it from the server. So first of all, it's gonna try to look for your resource in your cache. If it's there, you're good to go. If it's not, it's gonna make the request to the server and get it from there. So you can see how this is gonna help you increase the user experience. Then this is another life cycle, which is very important, is the activate life cycle. So essentially what it's doing is, in the activate life cycle, this code is going through my caches, right? And you can have multiple cache. Essentially think about it as an array. And what I'm doing is I'm searching for the names of the caches that I have, and I'm gonna compare it with this existing cache. In this PWA, I only have one cache. I only want to have one. So what I'm gonna do, I'm gonna update it to number 2, right? And what it's gonna do is, hey, I have 2 caches right now. In my progressive web application is cache version 1 and cache version 2. I'm on version 2 now. What do I do with version 1? Well, I'm gonna remove it. It finds it. If it's not the same name, remove it. So now I'm gonna save it. And then I'm gonna go back to my web app. And as you can see, the application refreshed and it says V2. So this is my cache version 2. So why don't we click on it? We click on it and you can see that I'm already caching my other images, my other shoes. So that's amazing, right? So now if I go to service workers and click offline, what do you think is gonna happen? I refresh it and voila, you have your application working offline. You have all your assets. Now I can purchase any shoes, doesn't matter if I have connection or not. Very cool. The last thing that I want to talk about is what can a PWA do today? So I only mentioned a few of the superpowers and some of them, they were a little bit different, like very technical, right? But this website right here allows you to see all the cool features that you can do by interacting with the features from your mobile device, right? For example, you can use the media capture, geolocation, the notifications, authentication. You can use the Bluetooth. Very cool things that you can do with PWAs. So take advantage of that to grow your business. And lastly, I want to share with y'all some resources, right? So if you want to take a screenshot, write it down or whatever, this website right here is the one that I previously showed you, where you can see the stats for other companies using PWAs, right? This is the website that I showed you with all the things that a PWA can do. This one right here is just a resource that I wrote for One Signal, and that shows you how to increase the user experience for emails. But you can apply the same concept with PWAs. And this one right here, this link is this article that I wrote about how to create a PWA with JavaScript. And as you can see, it's a series. I have the intro to PWAs and service workers, how to add notification, push notifications, social media sharing, and so on. So now I'm gonna open up the space for questions. So if you're not part of the Slack workspace, go to that website and go to the general channel. To the track 2 questions and ask any questions that you may have in there. So I'm just gonna give it like 2 minutes. If you have questions, throw them in there and ask me any questions that you may have. If for whatever reason you don't have any questions, that's great. But if you have questions later on, feel free to reach out to me on Twitter at devpato and ask me any questions there. Well, please don't send me a DM. Do it publicly. Why? For 2 reasons. One, because there might be other people that have questions around PWAs, right? And second, if you ask me something and I'm not right, someone can correct me. So think about it that way. So ask me any questions. Also, if you want a quick start with PWAs, if you go to my GitHub, this is my username, devpato, and you go to my repos, I'm gonna click on PWA. And I have some sample apps right here. The app that you saw today, which is this one right here, was built with this PWA template, right? All you have to do, go to GitHub, click on use this template. Now you have a shell, right? And the core or main things that you need to get your PWA running. And of course, you can modify it, extend it, make it better. You can install workbox and so on, right? So hopefully you learned something today. And I don't see any more questions, so I'm gonna let you guys go. Thank you so much. Have a good one.
Hello, everyone. Welcome to today's talk about React hooks. I'm Janhavi. I'm a software developer at Thunkable, which is a Y Combinator-backed startup based in San Francisco, where I live currently. I'm an avid reader, and you can always find me with a book in my free time. Also, I love traveling, especially to try out new cuisines from various places. So, before we move ahead, let's get a quick look at our agenda for today. I'll give a brief introduction to React so that even if you haven't had any hands-on experience, you might get a fair idea about what is React and its basic building blocks. Also, I'll be giving a brief idea about the life cycle of a React component, and then next we'll be diving into hooks. So what are they, why we need them, and how are they categorized? In the end, we'll see the rules to be followed when we decide to use the hooks and some recurring questions I have been asked about hooks always. So a brief intro to React. React.js is a JavaScript library for building user interfaces. So this is an official one-liner introduction about React.js. And the user interface here is a multi-option playground where the user can do anything, and libraries like React.js help us creating that playground. React is declarative in the sense that we write the code we want, and React is in charge of taking our declared code and performing all of the JavaScript and DOM steps to get us to our desired result. The architecture in React is component-based. So each React app contains components that represent specific screens or elements in the app. And React Native uses React primitives to render to native platform UI. So React creates platform-specific version of components. So a single code base can share code across multiple platforms. With React Native, one team can maintain two platforms like Android and iOS and share a common technology that is React. Let's see what is React Native. So it is a popular JavaScript-based mobile app framework that allows you to bind natively rendered mobile apps for iOS and Android. And also you can do proper native development and you'll get the look and feel of an Android and iOS app, even though you use a JavaScript-based code. React components wrap existing native code and interact with native APIs via React's declarative UI paradigm and JavaScript. So this enables native app development for a whole new team of developers, and they can let existing native teams work much faster. And this is my favorite one, fast refresh. It is a React Native feature that allows you to get near instant feedback for changes in your React components. So fast refresh is enabled by default, and you can toggle enable fast refresh in the React Native developer menu. But with fast refresh enabled, most edits should be visible within a second or two. And it preserves React local state in function components. And this is done by default in hooks too. And this leads to faster development and less build times, where if you have done native development, you are already familiar with how long the build times usually are. So this helps in that. Now let's look at the concepts of React, the two popular ones, the props and state. React.js being a component-based library, the user interface is divided into small reusable pieces. These components might need to send data to each other in some scenarios, and passing data between the components is done by way of props. As you might already have guessed, props stands for properties, and it is used for passing data from one component to another, usually between the parent and the child. And props are always read-only, you cannot change them. So once the data comes from the parent, the child can only use it and not change it at all. The next concept is a state. State is a built-in React object that is used to contain data or information about the component. A component state can change over time. So whenever it changes, the component re-renders, and this change in state can happen as a response to user action or system-generated events. And these changes determine the behavior of the component and how the component will render on the UI. The state object is initialized in the constructor, and it can store multiple properties. We use this.setState to change the value of the state object, and we'll look how to do that in the further slides. So React basically has two types of components, a simple component and a stateful component. So the simple component does not have a state, although it can get the values through props from its parent component. Here, you can see the first piece of code shows a functional component that takes in the name from props. And in the second piece of code, you can see that a similar result is achieved, but this time we use a class. So all the class components extend React component and have a render method. And the render method returns the content to be displayed on the web page. Now you might get the question that why did we go to the effort of creating a class when we can use the simple function as shown above to achieve the same results? So that's because until React version 16.8, we could use functional components only if we plan on using props and never state. So if you want to use state, we need to compulsorily create a class as seen in the stateful component. So this is our stateful component, and here name is a string in the state, and we can access its value using this.state.name. And the way to update the state, we'll see in the further slides. So that's basically this.setState. Let's take a look at the component lifecycle. The lifecycle methods are methods which are invoked at different phases of the lifecycle of a component. These methods are provided to us so that developer can produce a quality application and make sure the developer can really plan what and how to do at various stages of the UI interfaces. So there are 4 phases of the component lifecycle. The first one being the initialization. In this phase, the React component prepares by setting up the initial states and the default props. The initial state is set in the constructor, as we saw in the previous example, and can later be changed using the setState method. The default props is defined as a property of component to define all the default value of props, which can be overridden with the new prop values as we want in the component. So now that we have prepared the state and props, the React component is ready to mount in the browser DOM. So component will mount is executed just before the React component is about to mount. Hence, after this method, the component will mount, and all the things that you want to do before a component mounts has to be defined here. So this method is executed once in the life cycle of a component and before the first render happens. The next method is render. It basically mounts the component onto the browser. And the component did mount is executed once in the life cycle of a component and after the first render. Here we can access the DOM. So we should initialize the JavaScript libraries that need DOM access here. And also all the API calls should be made in the component did mount always, because that's where we can access all the DOM elements. Looking at the next phase called updating, it starts when the React component is now in the browser. So let's first look at the methods that get called when the parent sends new props to the child. So component will receive props, gets executed when the props have changed, and this is not the first render. So this is the method where we can update the state with the values of the new props, that is syncing the state with the props. Should component update tells React that when the component receives new props, should React re-render or not? So as you can see, this method name is like a question. Should component update? So basically it returns true or false. And if it returns true, the component updates. The component will update is only used to do the preparation for the upcoming render, similar to component will mount or the constructor. And as we saw before, the render method renders the component in the browser. The next one is component did update. It's executed when the new component has been updated in the DOM. So this method is used to make sure that the various third-party libraries we use in the code are also updated and they have reloaded themselves. Similarly, there are some methods which get called when the state gets updated. So you might notice that these steps under the states are a subset of the updating process of props. So they behave in the same way as we discussed in the case of props. Only difference is that they deal with the state instead of props. So now the component is in the last phase of its life cycle and will be unmounted from the DOM. So component will unmount is the last method in the life cycle and is executed just before the component gets removed from the DOM. We can do all the cleanups related to the component here. And now we can see that there are too many methods in the React lifecycle and so much to remember where exactly to use what. This becomes more difficult as our code base increases. And after continuous complaints and providing explanations for scenarios where one method is better than other, and to save us from all this, React has come up with hooks. So hooks are a new addition in React 16.8. They let you use state and other React features without writing a class. So if you're already using a class in your current React application, there is no need to change them. There are currently no plans to remove classes from React, and hooks don't replace your knowledge of React. So whatever you know about React is intact. It will just change the way you create components. So hooks are functions that let you hook into the React state and lifecycle features from the function components. So you can easily add a new component into your React app with the hook support, and it would not at all interfere with your current functionality. So you might have a question like, why do we change the way we currently code in React? And why should we go for React hooks? So currently, it's very difficult to use stateful logic between components. So hooks make our task of state management easier. With hooks, you can extract stateful logic from a component so that it can be tested independently and it can be reused. Hooks allow you to reuse stateful logic without changing your component hierarchy. So the component tree remains the same. And this makes it easy to share hooks among many components. Also, hooks let you split one component into smaller functions based on what pieces are related rather than forcing a split based on the lifecycle methods. So this makes them simple and more readable. Also, the last point is classes. So classes can be confusing, especially if you have a large code base. If you have experience with React, you know you need to bind the event handlers, and the code is lengthy, and the distinction between function and class components in React and when to use which just adds to the mayhem. So as React hooks totally avoid the classes, this mess can be avoided too. Now let's see how we can transform from a class component to a function component using the most basic programming example, that is the hello world. So this is a class component React, and like we saw before, we extend React component and have a render method which return the elements we need to show on the browser. Now, moving to the function component, the first thing I see is that we totally avoid the this keyword. and all the inconsistencies around it, which I feel is a victory in itself. And this one reason is enough for me to move to hooks. And we avoid the render method too, and the component returns hello world with the h1 tag. Of course, this is a simple example, so understanding the level to which function components simplify our life is a bit difficult uh, to visualize here. But when you have massive classes doing scores of things, the simplicity of moving towards functions will be more apparent, and hooks will let you do that seamlessly. Now, let's see what React hooks actually are. So React has three basic hooks, which you'll be using maximum number of times, and a few additional hooks that aren't that common, but have their own usefulness, and it doesn't hurt to know about them. So we'll go through each one by one and see how they work. So useState is a hook that lets you add React state to function components. If you write a function component and realize you need to add some state to it, until now, you had to convert it into a class. So this is a sample class that shows how we do it currently. Here we have a state variable called count, and we initialize it in the constructor. And we update the state on button click by calling the setState function. With hooks, you can avoid this process altogether. So let's say we have the function component here, and now we'll add state to it using hooks. So in hooks, we don't need to change it into a class. We can see the function keyword there. We import the useState hook and call it inside the function component. And we add some local state to it. So React will preserve the state between renders, and it returns a pair, the current state value, in this case, the count, and a function that updates the value, in this case, the set count. And you can use the function instead of this.setState as shown here in the code. So it just set count, and we can put the count value, whatever we want. And you can use the state hook multiple times in a component. It doesn't matter. And this is how simple it is compared to the class component and all the this and the set state, etc. So that's about useState. Next, we'll move on to the second basic hook, the useEffect. So React does not allow side effects such as mutations, subscriptions, timers, etc. to be implemented in the render phase. If we do so, we can get confusing bugs and inconsistencies in the UI. So to avoid that, we use useEffect. Whatever is inside useEffect will run after the render is shown on the screen. And by default, effects run after every render, but React provides a way of conditionally rendering too, which we'll see in the further slides. So now let's say you want to edit the document title every time the count changes. So without hooks, you will need to specify these two functions, component.mount and component.update, and add the same piece of code in both the functions. Using hook, you can simplify this with only one call to useEffect, and its behavior is exactly same as that of the two methods together. Now, let's say we want to update the document only when the count is different. So without hooks, we would use the component.update that has previous props and previous state parameters. We'll add the condition for checking the count, and only when it is different, we'll update the document title. Here, we can use the useEffect hook to do the exact same thing, but with so much more ease. This is called conditionally firing an effect, as we discussed in the previous slide. To implement this, we pass a second argument to useEffect, that is the array of values that the effect depends on. So in this case, it's the count, and the effect runs only when the count changes. So in this way, it is easier to understand, and hooks simplify the way we code. So instead of the three methods we saw traditionally used, we narrowed it down to a single method which behaves the same way. Moving on to the third basic hook, the use context. So use context accepts a context object and returns the current context value for that particular context. So the context object here is the value returned from React.create context, and it returns the current value. So basically what it does, it finds the nearest myContext.provider, which is above the calling component in the React tree, and then it reads its value. So what it does is whenever this value changes, use context will trigger a re-render using the latest value of the context provider. But we should keep in mind that this hook is only used to read the context and subscribe to the changes. It does not eliminate at all the need for the context provider to provide the value to us. So these were the basic hooks. Now let's look at the additional hooks. As I mentioned, these are not that common, but it's good to have a knowledge about them and know where to use which one. This is use reducer. It is an alternative to use state, and it returns the current state paired with the dispatch method. So use reducer is usually preferable to use state when we have complex state logic, and complex in sense that is usually used when the next state depends on the previous one. So it optimizes performance for components as it passes down dispatch instead of the callbacks. There are two ways we can initialize the use reducer state. First, by specifying the initial state, or by lazy initialization. So specifying the initial state is the simplest way to initialize the state. Just pass the state as the second argument to use reducer. So here we see we set the count value to initial count, wherein the initial count can be defined in our implementation and then pass the object to use reducer as the second argument. You can also create the initial state lazily. So to do this, we can define an init function that sets the initial count, and then you can pass that init function as the third argument. So the initial state will be set to init, and it lets you extract the logic for calculating the initial state outside the reducer. So, and this is also handy for resetting the state later in response to an action. So as you can see, we have a reset action here, which calls the init function with a new value. So the lazy initialization is helpful in such cases. The next one is use callback. So use callback returns a memoized callback. As you might know, memoization is an optimization technique, which is used primarily to speed up by storing the results of expensive calls and returning the cached result when the same inputs occur again. So we pass an inline callback and we pass an array of dependencies. This will return a memoized version of the callback that only changes if one of the dependencies, in this case, value 1 and value 2, have changed. This is useful when we want to prevent unnecessary re-renders when passing callback to optimized child components. You might notice that all the values used in the callback are present in the dependency array. Sometimes with larger code, we can miss this, so we need to give particular attention to it. And there are some packages that can be used to throw warnings in such cases, in case we have missed something like this. But although making it automatic would be the best solution, which may be implemented in the near future. As far as use memo is concerned, it is basically used for optimizing performance and returns a memoized value. So it's similar to use callback. We can have an array of dependencies and a create function. Here, the create function will only run when the dependencies change, or else it will return the same value. So the use case for this would be when in a project, we need to perform expensive calculations. So using useMemo, we can ensure that time is saved when the variables involved are the same. Now you might have a question that how is it different than useEffect? So the functions that we pass to useMemo, we can ensure that during rendering, they run during rendering. And the time is saved when the variables involved are the same. Also, you can see that useEffect is generally used for the side effects, and that shouldn't be run while they're rendering. So that's the basic difference between useMemo and useEffect. UseMemo runs during rendering and useEffect does not or should not. Moreover, we should be cautious while we use useMemo. There are instances wherein to utilize memory, React might forget and recalculate the values on future renders. In such cases, it's dangerous to totally depend on the execution of useMemo. So the React team encourages us to ensure that the code runs properly without useMemo, and then we add it for performance optimization. Moving on to useRef, let's imagine an empty space. This space is in your component, and we can put any value in it throughout the component's lifecycle. So useRef is basically that space, and the value is the DOM node. As you might know, primarily refs have been used to access the DOM. So if we pass a ref object to React, like with the input element in the code here, React will introduce a property called current. And whenever we access this current property of the ref object, it will give us the DOM node. It's similar to having fields in classes. Now you might get a question that if the useRef is essentially creating an object, why not we explicitly create an object? You realize that useRef gives us the same ref object on every render, and that's what makes it useful. Also, you must keep in mind that useRef does not notify us when the content changes. It just provides us with the latest value whenever we access its current property. If you want to run any code when the ref is attached or detached, you should use the callback ref in such scenarios. Usually, when you use useRef, you are given the instance value of the component the ref is attached to. This allows you to interact with the DOM element directly. Use imperative handle is very similar, but it lets you do two things. It gives you control over the value that is returned. So instead of returning the instance element, you explicitly state what the return value will be. Also, it allows you to replace native functions such as blur focus with the functions of your own, thus allowing side effects to the normal behavior or a different behavior altogether. And the plus point is you can call the function whatever you like. So basically, use imperative handle customizes the instance value that is exposed to parent components when using ref. So in this example, the value we get from ref will only contain the function focus, which we declared in the use imperative handle. Also, you can customize the function to behave in a different way than you would normally expect. So for example, in the focus function, we can update the document or title or console log anything as seen here. But notice that we have used forward ref here. In React, forward ref is a method that allows parent components to pass down ref to their children. And it gives the child component a reference to a DOM element, which is created by its parent component. So basically, use imperative handle is used when you might not want to expose native properties to the parent, or in our case, want to change the behavior of a native function. As in the case of additional hooks, you'll be rarely using use imperative handle in your code base, but it's good to know how to use it. As we saw with useEffect, the code in useEffect fires after the layout is rendered. Although this makes it suitable for, let's say, setting up subscriptions and event handlers, not all effects can be deferred. So basically, we should understand the difference between passive and active event handlers, event listeners. So let's say we want to make changes to the DOM synchronously before we render the additional components. If we use effect, this can lead to inconsistencies in the UI. So as a result, for these type of events, React provides us with use layout effect. It has the same signature as use effect, but only difference is it when it is fired. So your code runs immediately after the DOM has been updated, but before the browser has had a chance to paint those changes. For example, if you want to make DOM measurements like getting the scroll position or other styles of an element, and then make mutations or trigger synchronous re-render, in these cases, use layout effect as a guide. If you don't need to do all this, you should use effect. And most of the time, I'll go as far as to say 99% of the times, you would be using use effect. And now, before we go on with our last hook called use debug value, we'll need to understand the concept of custom hooks. So you might have heard a lot about custom hooks. We'll understand what they are exactly. Custom hooks are normal JavaScript functions which can use other hooks inside of it and contain a common stateful logic that can be used within multiple components. So these functions are prefixed with the word use, and you can name them anything once you have the use prefix. Let's say you have two functions or two components which implement some common logic. You can create a third function with this common logic and implement in the other two functions. After all, hooks are just functions. These give us advantage of fewer keystrokes and less repetitive code. I'll show how this happens, and we'll create our very own hook in the next slide. So let's say we have a count state variable and we want to store it in the local storage whenever the value updates. Use effect is the perfect candidate here, but what if we want to update this value in 10 other components? The highlighted code will be repeated in all these 10 components. And to avoid this repetition, we will use custom hook. So as you see here, we have created our very own hook called use local storage and added the repeated code to this hook. Now, in all our 10 components, we can simply call the use local storage hook and pass it the key and the default value. It's as simple as that, and it will work exactly the same as before. But with the introduction of custom hooks, people started creating hooks for the most common use cases. A simple search for local storage hook in NPM gave 60 already existing packages for varied use cases. So whenever you find a use case for a custom hook in your React application, I would recommend going through the list. Maybe someone has already created a package that you can reuse and save development time. This is one of the strengths of having such a vast and active community, and React has that, and you can surely put it up to your advantage. As you might know, if you have tried React, React DevTools is an amazing way to debug React apps. It shows a component tree with prop values while running the app. And use debug value is used to display label for custom hooks in the React DevTools. So for example, if we look at our custom hook example, we can display the state value of our custom hook by using use debug value, which will show us the label with the key as the hook name, and it will just remove the use word. And so it says local storage here instead of use local storage, and the value depending on the state value. We can pass an optional function to this hook solely for formatting purposes. That is for the data to look good when we inspect the components. We have to keep in mind that this is only for debugging and it won't be seen on the UI. This is just made to make the lives of developers easy when we go for inspecting elements. When we use the optional function for formatting, use debug value takes in the debug value and returns the formatted display just for the developers to see the data. So the data looks pretty and it's easier to understand. So now we know all about hooks. but they impose two additional rules. We to only call hooks at the top level. Don't call hooks inside loops, conditions, or nested functions. And only call hooks from React function components. Don't call hooks from regular JavaScript functions. There is just one other valid place to call hooks, that is your own custom hooks, as we saw in the previous slide. So yes, follow these two rules and everything will work as expected for you. So there are some common questions that have been asked multiple times, and I thought, why not just make a slide out of it? So yes, the first most commonly asked question is, should I recreate my entire app if I want to use hooks? No, it is not necessary to rewrite your whole app just because you want to use hooks. You can just use hooks in the new components, or in case you want to make changes to existing components. And hooks are made such that they can coexist with your current components and stay alongside the class components. The next question is, do hooks replace render props and higher order components? So basically, hooks are a simpler way to render a single child, which is what render props and higher order components do. We can still use them, but in many cases, hooks will suffice and it will reduce the nesting in your tree. Can I use Redux and React Router with hooks? Yes, you can use them as you do them now. React Redux since version 7.1 and React Router since version 5.1 support hooks API. And also many third-party libraries have added support for hooks. So it shouldn't be a problem if you use third-party libraries in your code. And the next one, do we need to make any changes while testing components that use hooks? This is a pretty common question. But answer is, a component using hook is just a regular component according to React. So it will not require any change in your current testing solution. You can continue using the current test methods. And if you need to test a component custom hook, so this is a difference because the custom hook is a new addition. So if you need to use the custom hook, you can do so by creating a component in your test and using your hook from it. And then you can test the component you wrote. So it's as simple as that. And that's the only addition. You can go through the React docs because they provide very simple explanation and a step-by-step explanation of how you can do the testing. So yeah, that's it from me today. I hope you understood everything well. And if not, feel free to message your questions on the Slack channel. And also, you can message me on Twitter. Here's my Twitter handle. And thank you all for listening and have a great day ahead.
started right on one. Looks like everything's set up. Oh, can you enable participant sharing? Or can you enable me to share? If you're coming in for the 1 o'clock session, I would encourage you to jump in the track 2 questions channel in the JavaScript and Friends Slack channel. That's where I'll be watching for questions or comments. So feel free to jump in over there and participate. One more minute and then we'll get started with a presentation on TypeScript beyond the basics. Hope everybody's been enjoying the conference so far. I know I saw some really good sessions this morning. Hope you did too. It would be certainly nice to be together in Columbus, but this is a nice substitute to be able to do it online. So thanks to the organizing committee that is putting the whole thing together. So appreciate their work that makes this event possible. So special thanks to the organizing team. That being said, why don't we get started? My name is Eric Potter, and I'm going to be talking about TypeScript today. We're going to be talking about some of the more advanced features of the type system. So I'm going to assume that if you're watching this, you already understand some of the basic TypeScript features, like how to put types on variables, how to define classes, how to set up a build pipeline, all those things. I'm not going to go over that. We're going to skip over that. I'm going to assume that you know that. We're going to get into some of the more sophisticated things that the TypeScript type system can do. So when we think about any language, a language is really a communication mechanism. And sometimes we have languages that are familiar, but there are subtle but important differences. A couple of years ago, my wife and I got to be in Australia, which is very obviously an English-speaking country. But they had vocabulary there that was new to us. For example, every time we saw an escalator, which seems like we saw a lot of escalators in downtown Sydney, there was always a sign that either said way up or way down. And so this was an up escalator. And so you can see there's an arrow here that says way up. This is, in fact, kind of helpful information to know what is going on. I've, in the States, never seen an escalator labeled this way, but it does say something about what the escalator is doing that is kind of helpful. TypeScript is kind of the same way with JavaScript. Obviously, I assume that if you are at the JavaScript and Friends conference, you know your way around JavaScript. And TypeScript feels very familiar. It's just there's some additional vocabulary. So today we're going to be talking about some of that additional vocabulary and how having the vocabulary can help you express your ideas to your teammates and to the compiler more effectively. Like I said, there are some prerequisites for this talk. I'm not going to talk about adding types or anything's covered on this slide. There are other presentations today that talk about TypeScript. There's a lot of resources online to help you get started with TypeScript. If you don't know how to do these things, I'm going to suggest you go check out one of those things. I'm going to skip over it. So what I promise will be a brief review of what data types are. A data type defines a collection of data and values and the set of predefined operations on those values. So we can think of a type as a collection of data and a collection of operations, or as we will often state it, it is a collection of state, which is what the class knows, and behavior, which is what the class can do. If you're not familiar, this is a like whiteboard level UML class diagram where you'd have the type in the top box, all the state in the middle box, and the behavior in the bottom box. Right. So if we have some type, there could be certain data fields and certain functions, and all those things can have types. So if we're defining a person class, the person might have a field for first name that is a string, a field for last name that is a string, and there might be a function called getGreeting that also returns a string. I assume that you understand that this is how types work. I just want to make sure that we're all using the same vocabulary so that the rest of my examples make sense. The first, maybe the first more advanced feature of TypeScript that a lot of developers get to is generics. This is because generics are very common in a lot of other languages, but JavaScript doesn't have them, partially because JavaScript doesn't need them. JavaScript is a dynamically typed language, so generics don't really matter. If you come from C#, you understand the power of generics. And so TypeScript, being a strongly typed language, or a language that can be strongly typed, does in fact have generics. So when we have generics, really what we're saying is we want to be able to find a type, and we want to be able to define part of this class definition later. So we can have a type of T where not when we're coding it, but when it's running, we can define that one of the fields, one part of the state could be of type T, and one of the functions could return something of type T. And you could do the same thing with parameters or any other types in the class. And TypeScript supports this. Notably, where generics become very common is in collections, which collections are a class that holds items of some other class, like an array. JavaScript has arrays. You can put objects in arrays, but there's no control over what type of object goes into the array. In TypeScript, we can define an array of T, and then the fill function takes a value of type T, which means that we can only fill the array with items of type T. If we look at an example of this, let's say we are trying to solve a simple chess puzzle. If you're familiar with the 8 queens problem, this is a solution to the 8 queens problem. And what I need to do is have an array of queen. So in doing this, I can say that when I assign a new queen into this array, down here on this line, oops. Right, I can say this dot queens I equals a new queen. If I attempted to assign a string or an integer or any other type of class that is not a queen, this line would fail. I'd get a compiler error. Whereas in JavaScript, if I tried to assign a queen into this slot in the queens array, it would accept it. You might not see the issue of putting an object into the array. The problem becomes when you get it out of the array. So when I come in here and I want to call the solve method on an item in the queens array, if I know that every item in this array is a queen, I can call the solve method without having to check if that object is of the queen type. And so it saves me some type checking on the way out. So this is the TypeScript code, but I want to look at the JavaScript code for this. Now, all TypeScript compiles down to JavaScript. And so in fact, I wrote this TypeScript code, I ran it in the browser, and I looked at it in the browser tools as JavaScript. And this is what it looks like. So you'll notice my array is still there. I am saying a new array, but I'm not saying of type queen, it's just an array. I bring this up to highlight something about TypeScript. The type checking in TypeScript and all the features we're going to talk about are specifically for compile time. When it's compiled down to JavaScript, all these runtime type checks go away. At that point, we're just back down to a dynamically typed language that is JavaScript. Obviously, that's not a huge problem because JavaScript runs great. TypeScript gives us type checking while we're coding. So it helps us avoid mistakes when coding, not necessarily when running. All right, another quick refresher, just so we're all in the same terminology. Let's talk about inheritance. If you're familiar with C# or Java or any other object-oriented language, you're familiar with this concept where you can have a type, and that type can have a child type. The child type can either add new state and behavior, or it can refine and change the state and behavior of its parent type. And so it's kind of both an additive and a refining change. But the important thing conceptually is to remember that inheritance produces an is-a relationship. So if I have a person class and I have a programmer class, I can say that a programmer is a person. And so we can go beyond just what we might be able to do with like sharing code. Because if you're just trying to share code by having common base class, you're going to run into some snags eventually. But if we stick to having this is a convention, then things work pretty well. And so we can see in TypeScript, what I can do is I can define a class person, and then I can define a class programmer, and I just say programmer extends person. And that works pretty well. That's the basic inheritance. Oops, hit the wrong button there. I do want to say before we move on that while inheritance is great, it does have its own issues. And a lot of the complaints with object-oriented languages is that people overuse inheritance. So when possible, we want to prefer the design patterns that use composition over inheritance. But that being said, there are some really interesting things we can do with some of the more advanced TypeScript type system features. One of those is intersection types. So let's say that we want to have our programmer class, but then we also want to have a class that represents billable resources. So maybe there's a consulting company that also hosts websites, and so they want to be able to bill for time hosted on their server. And so there's like this get invoice amount that is a billable resource. We also have a class for programmer that stores the programmer's favorite language. Maybe there's some like kind of greeting that they have. But sometimes we want to have both of these. You can imagine a situation where there's a consulting company that has a programmer that is a billable resource. But not all programmers are billable resources. So we don't necessarily want to say that the programmer inherits from billable resource. We certainly don't want to say that billable resource inherits from programmer. We just want to be able to say that sometimes we have something that is a combination of both. And that's where these intersection types come in handy. So let's say I'm going to define a programmer employee, and I'm going to define an interface for billable resource, right? You can see the fields here for first name, last name, and favorite language in programmer employee, and billable resource has an hourly rate. So what I can do is I can define a class or a type that is both. So you can see there's this ampersand here in the type definition. So we're going to say that the billable programmer is both a programmer employee and a billable resource. So let's actually jump over to some code and look at this so you can see it a little bit more in real time. Right. So if I have a programmer employee, I can call get greeting, but I can't say rate equal p dot get invoice amount. Like, it's not a thing because this is a programmer employee, not a billable resource. Same thing with the billable resource. I can't ask the billable resource to get its greeting, right? Because it's a billable resource and not a programmer. But with an intersection type, what I can do is I can create a new variable, Don, that is going to call this extend method. And extend is going to combine the programmer employee with the billable resource. So now I can call, and actually if we hover over this, you can see, there we go. We can see the intersection type noted here is the ampersand of both programmer employee and billable resource. So now I can call get invoice amount on the Don object, and I can call get greeting on the Don object. So this now has all of the state and the behavior of both classes in the intersection type. Now, if we downcast our intersection type to one variable or the other, if I have this Don variable that is the intersection type of programmer employee and billable resource, but then I downcast it into just a programmer employee, now you can see oops. Let's do this. This won't compile because it now knows that prog is just a programmer and not necessarily a programmer employee. Although in this case, it actually could compile, but because we told the compiler that this is a programmer employee, it won't allow us to call methods on the billable resource type. And the same would go in the other direction as well, where once we had downcast Don to a resource, we couldn't call get greeting. All right. Any questions on intersection types? Oops. Okay, we looked at that. Now, the next thing that I want to look at is the union types. A union type is saying that I want to have a variable that is either going to be one type, the first type, or the second type. So I might have a situation where what I want is to be able to say that I've got a variable that could either be a programmer or a tester. imagine a situation where we are maybe designing a system that is going to represent our Kanban board in our workflow management. And there are some things that, like, we want to be able to assign a task to a programmer or to a tester, but not to the product owner. So what I could do is I could define my 3 classes, one for programmer, one for tester, one for product owner. And then I could define a class for the sprint task. And in the sprint task, I've got an assign method, and the argument to the assign method is programmer or tester. Or you could also think of this as the union type of programmer or tester. And so then I could assign whatever this person parameter argument is into the assign to parameter. Again, let's jump over and look at the code. So I've got, this person that is the union type of programmer and tester. Now, it happens to be that both tester and programmer implement the get name method. So I can actually call get name right on person because the compiler knows that either of those types has the get name method. If I, on the other hand, were to try and call the get favorite language, this won't compile. I actually get a really helpful error message here, where it will say the get favorite language does not exist on type programmer or tester. And it will further tell me the get favorite language does not exist on the programmer, which, let's see, I thought, oh man, I feel like that compiler error might even be wrong. Unless I've got a typo in there. Anyway, it knows that I can't call get favorite language on this object because tester doesn't implement it. But what I can do is pass in a programmer or a tester, and it will do the assignment. Now, if we're going to look at some code that calls this, we can define a programmer and we can define a tester. We can define a sprint task. And so we could either call assign and pass it the programmer P, or we could call assign and pass it the tester T. And both of those would work. But if we tried to create a new sprint task and a new object of type product owner, and we uncomment this, now we'll get a compiler error because product owner is not assignable to the parameter of type programmer or tester. So we can absolutely now have a parameter that is exclusively one of those 2 types. We could union more types together too, if that was really what we wanted to do. But the idea being that we can kind of mash those types together and get variables that have interesting characteristics. Now, union types are interesting, but there is one use case for union types that is much more common than any other. And that is the idea where union types are used to safely represent potential error cases. So I'm sure you guys have all worked with databases at some point in your career. So let's imagine that we now have some kind of database that stores information about our teammates on our software development teams, or in this case, specifically programmers. We might have a class that defines a programmer, which is here on lines 1 to 9. And we might have an error case for that of type lookup failed. And so what we could do is when we go to look up the programmer in the database. If something goes wrong, we would want to return a lookup failed object. Now, in languages that don't support union types, you could do this a couple ways. You could have a function that returns the programmer when everything works. And if something fails, then we would throw an exception. Exceptions are kind of messy. You either have to have a language like Java that makes the calling class declare what type of exceptions it handles, or in C#, you have the possibility of just having an unhandled exception, which in some cases can actually crash the page or crash the program if an exception is completely unhandled. And so what we might want to do instead is, instead of throwing an exception, we're going to return a programmer lookup result. And I've actually done an export on my type. So I'm going to export the type programmer lookup result that is the union of programmer and lookup failed. So now when I've got my repository method, I can have a class that has a function called getByName that is going to return a programmer lookup result. Again, let's jump over to the IDE. So, oops, where did you go? Oh, I wanted this one. Here we go. So here's the code. I've got this programmer repository. You could imagine pretty easily a scenario where the code is doing something interesting. And then, if something goes wrong, let's say the connection times out, let's say the database is not available, let's say maybe there's a permissions issue, we can return a new lookup failed entry. We could, of course, also, if everything went correctly, return a new programmer. Which I need to initialize here. And so now my method just has a single return type and there's no exception that needs to be thrown. I'm just going to return one of these two things, either the programmer or the lookup failed. This has some nice ramifications. So if we look at some code that might be calling this, I can say I want to look up the result from my repository. I'm going to get a programmer by name. And the result is either going to be, right now it's not used, so it's giving me a message just saying it's never used. If I look at the type of this method, it's returning a programmer lookup result. But let's say that I want to, let favorite language equal results dot, and I want the favorite language, and I know from my definition that there is a get favorite language method, but I can't call this right now. And it's telling me that the reason I can't call this is property get favorite language does not exist on programmer lookup result. Further, property get favorite language does not exist on the type lookup failed. So I can't call this yet because the result might have been an error. So I can't guarantee that the result is a programmer that has a favorite language. Now, the compiler is pretty smart. And if I say if result instance of programmer, oops, this is a programmer. now the compiler is smart enough to say, okay, well, this instance of was called. And so now we know that result is a programmer. And so I can call get favorite language without having to cast anything else. But what I've been forced to do is before I do anything interesting with the result, I've been forced to admit that it might be an error. So really what I would want to do is say, else if result instance of lookup failed. Oh, I've got curly braces instead of parentheses. Let me fix that. Right now I would want to do something interesting with the variable here. But I wouldn't necessarily need to do that. But the compiler has now kind of forced me into the pit of success where while I suppose I could still not handle the error case, unlike an exception where I can just code away and not have any indication that there might have been an exception, I now have to at least deal with the fact that there was a union type. Yeah, so this is what it would look like. All right, before I go on, are there any questions about union types? I'll take a quick drink. All right. So another one of the advanced features of the type, oops, okay, we've got a question. John asked, a question for the intersection types you talked about earlier. If two types involved happen to share similarly named data or a member function, how does TypeScript handle this? Union specifically deals with this with shared data, a member function, but I don't know what would happen if the two are present in an intersection. Good question. So one of the things that's interesting about intersection types, let's see if I can find this. Oops, that's my spec file. I want. So this extend method that I was calling here to extend billable resource, that's not a built-in function. That is actually a function that you have to define yourself. So right now, I've got like a last one in wins type of extend method. So basically, I am going to define a new result as a partial of first and second. And then basically this partial is going to get all the properties from the first. And then for all the properties in the second, I'm going to mash those on as well. So in my current implementation, which is fairly naive, if the first and second type had either the same field or the same function, or at least they had the same name, which the one that's in the second class would win. This is code, so you can customize it to be however you want. I do think that's one of the kind of squirrely things about intersection types is that you can define it however you want. So you would think that would be something that was more standardized. Any other questions before we go on to string literals? Okay, well, I will watch the chat. We'll come back. Well, you'll have some more chances where I'll specifically ask for questions. String literals are a feature that really fascinates me in TypeScript. And this is the idea that we can say that a string is not necessarily any string, but it has to be one of some predefined set of strings. So I might have a type grade that could either be A, B, C, D, or F. And so if we do this, now we have a string, but it couldn't be any string. It has to be one of these 5 strings. And we could have an enter grade function that instead of taking a string, takes a grade. Jump back over to the code. There you see it. So if I try and assign a grade, I'll pass in a name and a B, this compiles without a problem. If, however, I try and call the same method with a line of code that is in fact passing a valid string, I still get a compiler error because it says the argument of type E is not assignable to the parameter of type grade. Now, one of the things that people often say when I bring this up is that it's not really that different from an enumeration. And in some ways, you're right, because the enumeration, I could also have an enumeration of grades A, B, C, and D. Actually, to make it complete, let's add the F. There we go. Right, we could do this, and we could represent the same domain this way, but the type would be different. Because remember, in all languages, enumerations are basically just mnemonics over integers. So in JavaScript, in C#, in whatever, if I have an enumeration, even if it is the letter A, because that's the first one, that is effectively a 0. In fact, the IntelliSense is telling me that my grade.A equals 0. I'm just giving a name to a numeric value. With string literals, I'm actually using strings. So anything I can do with a string, I can now do to a grade. I just can't assign it to any value other than these 5. This becomes really useful because as we're writing web apps, we are often doing some kind of string manipulation. So you might imagine a situation where you want to do some DOM manipulation and you want a certain function to be able to take div or P as an argument, but not A. So you could do that, and you could just be working right with the string values for those different tag names. You could just constrain it to these various strings. Now, it is also worth noting that you can have numeric literals. So you could say the dice roll could either be 1 or 2 or 3 or 4 or 5 or 6. And I could imagine situations where that is useful, although it does get closer to just what an enumeration is. I suppose it's somewhat valuable if like you don't want to have a different name for it and you just actually want the number. But I think string literals are one of those things that is somewhat unique to TypeScript in my experience. I've not seen other languages that have that. Any questions on string literals? One thing that is worth noting, you could also do this with floating point numbers as well. So I could say type special numbers equals 3.14, oops, 3.14, or 2.4, whatever. So I could do this too, where I have floating point numbers, but again, I've not seen that to be as useful as I have with these string literals. If you guys have cases where these numeric literals have been useful, I'd love to hear about it. Any questions on string literals before we wrap up? All right, so one of the things that I always want to bring up when I talk about some of these features is that this isn't a game where you're trying to see how many advanced features you can squeeze into a code base. No more than this presentation is a game where I'm trying to use the largest vocabulary. In the same way that people that try and show off their vocabulary irritate people, listen to them. If you try and cram all of these features into one code base, you'll irritate the other people on your team or the future maintainers of the software. So don't think that you could, or I guess you could, don't think that you should use all these features in a project. What you're looking for are the times when these types properly model the domain you're going for. That's when you want to use them. Don't use an intersection type just because it's there. Use it because you have a situation where you need to combine the state and behavior of two classes. Don't just use string literals because you now know what they are. Make sure you're looking for a constrained set of strings. What you want to do with the type system in TypeScript is to clearly express the intent of your software to the compiler, right? Hopefully what I've done today is give you some additional tools to be able to do that. Now, if you want to see and play with the code that I showed in this talk, that is available on GitHub. It's in my GitHub repo, so github.com/PotterEric/TypeScript Beyond the Basics. If you want to see these slides, they're at slideshare.net /EricPotter4/TypeScript Beyond the Basics, like it's written out there. If you want to connect with me, the easiest way is to hit me up on Twitter. I'm at PotterEric. I have blogged about some of these features on my blog, which is humbletoolsmith.com. And so you can find more information there. I'll do one more quick check of the chat to make sure there's no questions. It doesn't look like they are. I tell you what, I'm done here. I will hang out for another 5 minutes or so. If you have questions, you can post them in the chat. If not, I thank you so much for your time and attention. I hope this was useful to you, and I hope you are now more equipped to go out and build great software. Thank you.
Okay. It looks like I'm live here, and yep, just got that verified. So we'll start the talk here. First of all, I'd like to thank Bhaskar and all of the conference folks. I know that what they've gone through today to keep all this running smoothly has been quite impressive. There have been small glitches. There are always small glitches. Even if you go in person, there are small glitches. I've helped out planning, organizing conferences before, so I know what these guys are going through. It's kind of crazy. So, having said that, ready to jump into my talk on asynchronous JavaScript living on a prayer. As you see up at the top there, it's gone through several iterations in the title. But basically the talk, a little bit about me before I jump in too much further. My name is Bob Fornal. I'm with Leading Edge. I'm a senior solutions developer. I've been writing web pages in general for the last 9 years. I taught computers 25 years prior to that, including design and development work. The last 5 specifically have been with Leading Edge, which is where this bright green color scheme has come from. And bouncing from project to project. So I do a lot of work in Angular, a lot of work in React Native, and Vue. So I'm kind of all over the place in skill set. And at one point, I was starting to get some questions from some devs on the synchronous nature of JavaScript, or as they put, the asynchronous nature. JavaScript is not asynchronous. It is a synchronous blocking single-threaded language. So essentially with each browser tab, you have one thread. And only thing happens at once. Now, there are a lot of things that occur. So you fire off a request for something, the data comes back at some point, and the users clicked on something in the process, and the page is starting to change, and data is loading, and that kind of stuff. So it seems very asynchronous. And we're going to talk here about how, and we're going to show through a semi-live coded tooling I've got here, which is why we have the console log open on the right. I am going to try and keep track of the questions, although if you want to ask questions after the talk, that's fine too. And that's in the Slack channel too. All right, so let's jump into this a little further and see what we've got. Okay, so got to dig into definitions. Okay, it's helpful in understanding that we have the same terminology. So parallelism, multi-threaded processes, scheduling, things occur at the same time. Asynchronous, single thread with an event loop. So asynchronous does not mean in parallel. It means it can handle things without understanding completely the timing that it has to occur. Okay, does not indicate that they occur in parallel. We're managing that asynchronicity via concurrency. Higher level tasks occur within the same time frame. We deal with contention, multiple things that need to occur as close as possible to the same instant. Okay. Essentially, the cooperative concurrency that we talk about there, we have a queue, and the queue determines what happens next. There's some control over what happens. Okay. This should be the last page of definitions, and then we'll start actually digging in a little bit here. Okay. So JavaScript engine details. It was interesting to me when I started digging into synchronicity, asynchronicity, to find out that the JavaScript engine itself doesn't handle set timeout. It doesn't handle the event loop. It doesn't handle web APIs. It doesn't handle message queue. It doesn't handle the tasking queue. That is all up to the browser itself. So if we look at the queues here, okay, you have the single threaded environment down across the bottom, the JavaScript runtime, the heap handling one thing at a time there, and it pushes things onto that stack. Potentially, if you're sending an AJAX call or you're updating something on the DOM, that gets pushed off to those web APIs. Those APIs do their thing, and they push something back into the callback queue. The event loop controls that callback queue, and that callback gets pushed back onto the stack, and one thing at a time occurs there. and you can see why we've got this nice loop here. Okay, it all comes down to how the browser handles things. Okay. So next slide here. In earlier versions of JavaScript, people started to realize that, hey, we need a way to handle something happening later. We don't know when it is. And, this is where promise chains and callbacks and the pyramid of doom and all of that, and inversion control, which becomes an interesting one because I talk about how we hand off things and we don't know what's going to happen. It's inversion control because we have control over that code that we don't hand off. But as soon as I hand something off for a callback, I'm handing off that function saying, hey, when you're done with it, do something with it. But I don't know when, if it's going to occur. I don't know if it occurs correctly, if it does what I expected it to do. I've given the control away. Okay. What happened through all of this as we went through using callbacks to handle asynchronousy, as we started to work with promise chains, and now we have async await, which wraps around the promise chains and those kind of things. What people realized is that using callbacks in that pattern is nonlinear thinking, and most people are have linear thought processes, and trying to determine what's going to happen through essentially a temporal dependency requires some odd nesting, which is where the pyramid of doom comes from. Okay. All right, so that's what we're going to go into. Sounds exciting, doesn't it? It sounds kind of terrifying when you're first trying to put this talk together. So first thing I'm going to do is I'm going to go through a thought exercise here, okay? And it's going to show you how I'm going to use that console on the right, how I'm going to be showing code, executing code, so we can start thinking through what we expect to happen. We're going to look at synchronous code. We're going to look at some non-asynchronous code. We're going to look at some simple network code, complex network code. I'm not actually firing APIs. I'm simulating that. We're going to look at some promise code, and simple and complex, using ES 2015. And I had to split the overview into 2 pages because it didn't always fit on the screen. And we're going to go through generator throttling code. Generators were a fun one. I learned a lot about that when going through this. We're going to look at user interaction. We're going to look at event listeners. We're going to look at web workers. And there's an interesting one when you talk about parallelism and multi-threading. We're going to look at race conditions, timing code here. And hopefully it doesn't crash. I've done this talk half a dozen times now, and in the hundreds of tests, I never had that one do something unexpected, except for I think it was the second time I gave this talk and I did something unexpected. Figures in a live environment, live code. But we'll see what happens there when we get to race conditions. Now we're going to look at the set timeout timer, and we're going to look at ES 2017's async await and what happens there. Okay, and there are code examples for all of these. So the thought exercise. And what we're going to do here is we're going to show the code. And this is not a complex example, but what I want to show you is how I intend to use the code. So you're going to see me looking over to the right here. First thing to look at is we have that underscore time up at the top. Think of this all as one class, essentially. Okay, and that underscore time is attached, so we can reuse that through our functionality. So you'll see my functions are on average about 5 or 6 lines at the most. So that change layout is probably about the longest you're going to get. The reason I do that is console log shortens that and abbreviates if I go further. So I've fit all these in here, and you'll see I mangled up a couple of functions here and there to make it fit that pattern so I could show the code easily. Okay, so start triggers things off. So when we're looking at these examples, that's where we want to begin. And there are a couple of cases where I start and we branch through the starts, and you'll see that too later on. But here we have a button it's called a thought button. We're getting the element, and we're removing the hide class. Thought behind that would be a button shows up. And then we add an event listener. Okay, the event listener fires this.event. So if you look up, there's this.event. It changes the color, it changes the layout, and it fires a wait function. So we look at the change color. It's nothing too complicated there. We're getting a wrapper, which is the thought wrapper. We're applying a color red. The changed layout. We are creating a paragraph element. We're setting its attribute, giving it an ID. We're setting inner text thought exercises. We're appending that to the wrapper, which is the, where did we set the wrapper? Wrapper up above that was set and change color. So we're appending it to the document, okay? And then the next one we're doing is the wait. And here's an interesting one. We set a start time, and we have it loop until the time has 10 seconds has elapsed. So generally I would ask questions, and if you're on the track 2 question thread, feel free to answer there. The question is, what do you think is going to happen here? Well, we're going to open the button up so we can click on it. When we click on it, the event's going to fire. Change color, change layout will fire. Now, this is an asynchronous talk. This is a talk about how things happen, how timing works. And we're going to have that wait function that executes. So the thought is what do you think is going to happen? Well, number one, you know something's going to turn red. You know there's going to get some text that's going to get added. My question is, based on what you're seeing here, is when do you think that's going to happen? Okay. Not seeing any answers, so I'm going to just move forward. I don't actually have the YouTube open, so I can't answer any questions out there at the moment. I'll check that after the talk. So without anyone popping up a potential answer, what I'll tell you is 2 things could happen. Could be read first with the text, and then the timer runs through, and we finish. And what actually happens is the timer is going to run. And let's go ahead and run this code, which gives me the click me. The timer is going to run 10 seconds. Okay, so the wait is going to cause essentially a thread lock for that 10 seconds. And at the end of the 10 seconds, it should change the color at that point and then add the text. So I got to talk here for just a little bit longer until that red thing occurs. And we're in the console, so if anything weird happens, we'll know that. Man, that seems like a long 10 seconds. In the back of my head, I keep saying I need to do this about 5 seconds for the talk. Yeah, that's a really long 10 seconds. Try clicking again. Oh, we are locked up. Notice we're thread locked. I'm not hovering, I'm not clicking. And I'm not sure why that 10 seconds is taking so long. Okay, I'm going to refresh and we're going to try this again. This is what happens when you try it live. And for those of you chuckling out there, yes, this is why this one could be nerve-wracking. I'm going to refresh this as well. We're thread locked, so it may take me a second. The while loop is locking things up. As I said, it's only crashed once before. Good for 2. And for anybody that's thread locked your browser, now you know exactly where I stand. Console just did something. Come on. Okay, I'm going to close this tab. Yay. All right, we have to re-display it. Oh, the slide notes was not even. There we go. Page unresponsive. There we go. Page is back up. All right. So let me get the slide back open, get the slide back over here and open it up and F12 it. And yeah, I haven't crashed that particular page before. So that's a new one for me to crash. Share. Okay, so we're back up. Hey, let's get back to our slide. All right. So we're going to run the code, thought start. We're going to click the button. It lets me hover there for a second. 1001, 1002, 1003, 1004, 1007, 1008. Don't crash. Supposed to happen. Okay. I apologize for that delay on that. Let me get my browser opened up just a little bit wider for you here. There we go. All right. Cleaning things up. I'm going to clear that out real quick. All right. So we're going to go back. That was a thought exercise. It's just designed to show you how I'm going to use the code, okay? So we have non-asynchronous code. This is the next one we want to do here. And let's show our code. Okay, and if we look at the debug start, it turns on the debugger and it runs an async function. And as we go up here and look at start, we're setting it initially to async false. We're going to run it synchronous, okay? And in that case, we're going to fire off run sync, which is this one up here that'll console log the start. It's going to set up a for each sync, and the for each sync is going to do something. We're going to pass in a function that takes a number and multiplies that number by 2, and then it's going to fire the end. So the question there becomes, what do you think is going to happen? We have options of the start, the numbers 1, 2, 3 multiplied by 2, and the end. And the question becomes, what order do you think that's going to occur in? So I get everything from, you're going to get the 1, 2, 3 first, you're going to get start first, you're going to get the start, the end, then the 1, 2, 3. Let's run it and see what happens. So we're going to run the non-async, and it's synchronous. They occur in order. So the one that displays the console log for the 2 has to occur, then the 3 has to occur, then the 4 has to occur before the end one occurs. Okay. So if we do that same thing and we run the option where we have it true and it runs the async, what we see up here is we have a console log, we have a for each async. Now in the async, we have one small difference. Instead of just firing the callback we did in the sync, we're running a set timeout around it. Now it's a 0 second set timeout. We're passing an item, but it is still a timeout. So the question is, what do you think happens here? Get all kinds of answers here. Okay, let's run it and see what happens, and we'll talk about why. Okay, so here, it starts, it ends. We see 2, 4, and 6 occur after the end. Okay, that 0 millisecond callback puts it into the event queue. So the other things occur first before it comes out of that event loop. Okay, now this also brought something else up that I like to talk about when I get to set timeout, which is set timeout does not have the option for a 0 millisecond set timeout. And later on, we'll see that there is no 0. I've got an example here that will give us what our current browser is doing. And I've seen everything ranging from 4 to 10. The default by the standards for JavaScript is 4 milliseconds. Some browsers run longer. If you're running a really slow machine, run even longer than that. Actually, I haven't tested this particular machine to see what the value is there. All right, so I'm going to run this with the debug. And if we notice, we just had the debugger on there. I'm going to run the async debug. And the async debug gives us an interesting little thing. And what I wanted to point out here is when I first started using the debug, I used it far enough back that for asynchronous activity, you had to turn on an asynchronous watcher. When I went to write this talk, I was looking for that asynchronous watcher, and somewhere between first having to do that and putting this talk together, it disappeared because it's now built into it. Okay, so if you notice, we have the synchronous debug start. We're paused at this point on the main, and I'm going to go ahead and step through, and we're not paused, and we have threads and things going on there. Well, let's get rid of it. Get rid of the console at the moment. I'll pull that up. There we go. Okay. And we see fetches and things like that occur. And I lost my restart. Where did my restart go? Oh, it finished. Sorry. But what happens is, so you can see those asynchronous activities now within the debug. It's something that now occurs without that. Okay, so let's close that out. Let's close that. Oh, not what I want. Sorry. Man, I am messing up all over the place. I want to go back to the console. There we go. All right. So we got through the non-asynchronous code. The next one we're going to look at is a simple network. And I want to show you the code here. And when I say simple network here, I'm using the set timeout to simulate a network request. It's a 10-second network request. Okay. So we have the start, the end. We have a console log in there that's going to fire. Supposedly at that 10 millisecond time point. And in theory, we should see the start, the end fire, and then the async after that. But let's fire it and see what happens. Okay, we're simulating a 10-second delay on data coming back from the back end. Okay, in this case, we're using callbacks to handle that network activity. So when it finishes, it's firing that function we passed in. So when set timeout finishes, it's executing a function. Okay, we handed that function off. As you saw when the application crashed on me earlier, I handed control off. I had no control of whether that was going to fire or not. Okay, and as we nest things, they get harder and harder to read. and displaying them in the console log, they get harder and harder to read as well. So looking at a complex network code, let's take a look at that code. Now, complexity here, I console log the number 1, we fire first. Okay, so we come up there and look at first. First has a set timeout. It's wrapped in a 0 millisecond timer. It console logs 2, it fires second, which is also in a set timeout, which has 3 console logged, and then 4 fires after second inside the first set timeout. And then we come back to start in console log 5. So this could be 1, 2, 3, 4, 5. It could be 1, 5, 2, 4, 3. It could be 1, 5, 2, 3, 4. Let's find out. Okay, and we do that by starting our complex example. And look, we get 1, 5, 2, 4, 3. So what happened is the set timeout for first went onto the queue and it came off the queue. Okay, after the end, or after the 5 console log. It came off the queue and it put second on the queue, which is the one that console logs the 3. And it executed its 2 and 4 console logs. Okay, interesting stuff there. Okay, so something about it, we can start to see how that control is happening. Now, looking at promise codes. Okay, promises. I don't know how much you know about promises, so we're going to jump in real quick. A promise can only be resolved once. It's either a success or an error. A message is passed / kept through the chain of the promise in the thens and the catch. Any exceptions become errors, and it's immutable once it's resolved. Okay, you can't change that resolution after the fact. So what did this simplify? It simplified things on passing values, on the nested syntax, on handling failure. We still have some nested syntax as we deal with promise chains. So let's take a quick look at our code. We have a console log start and end again. Inside, we have a timeout, which is very similar to what we've seen in timeouts before. And then we have a promise right below that. Okay. And the promise just does a resolve. In the then, it console logs the resolve. If it rejects it, console logs the error. Hopefully we don't have an error in this one. There's no error written into the code, but we're going to see what happens and see what the order is. So the question is always, do you think the promise is going to finish first or the timeout? And the interesting part is we look at this, we get the start and the end right off the bat, which we expect. The timeout and the promise should fire some point after that. But if you look at this, the resolve resolved first before the timeout. So promise chain is handled synchronously. It's interesting how, but it allows us to maintain a level of control over what's going on as well. So jumping into a complex promise, we'll take a look at the code here. On the start, we're doing a timeout, and we have a promise 1 and a promise 2. And the promise 1 resolves 1, and the promise 2 resolves 2, and then it console logs another time where it executes a promise 3. So the question is are we going to get, as we expect, the start, the end, resolve 1, resolve 2, resolve 3, coming back and executing the timeout, or are we going to get something in the middle of that? So let's start it up and see what happens and talk about why. Hey, look at that, resolve 1, 2, 3, and the set timeout fired just as we expected. Okay, so that promise chain that fired that activity synchronously resolved things as we expected. Okay. So now let's take a look at generator. Generators are one that drove me a little bonkers when I first started using them. They're essentially I'm going to pull the code up while I do that, and you can read through the code. They're a syntactic form of a state machine. Okay, it's about resolving the reasoning about issue. Okay, we allow non-run to completion behavior, localized blocking, and essentially a generator returns an iterator, an iterable. It becomes iterable. We can loop through it. Okay, and I've been looking for examples of throttling and how we can throttle, or how we can use, I've been looking for ways of using generators, and throttling wound up being one of those ones. So if we look at this code, we initialize the throttle. Okay, so we set up throttle, it runs the machine up above, so the generator is executed. Okay, the throttle next that you see in the start, you have to fire it 1 time for it to be active. Okay, after that, it throttles over a timeout time frame, which in this case is 3 seconds. So it doesn't allow a next to be fired within that window. It only allows 1 to be fired within that window. At the end of that, then it allows us to step forward again. Okay, if you've worked with searches, this kind of throttling is what I'm talking about here. So I'm going to start up, and I got 3 seconds to repeat. I'm sending a whole bunch of them over this window. So I sent 19 send a comments. And at the end of this, we execute out, we yield the one throttled console log, which is send a comment one time, not 19 times. Okay. So that's a level of asynchronous activity as well, in that we have to deal with what the user is doing in a logical, responsible way. Okay. The generators do help there a little bit. All right. So drag and drop, user interaction. Okay. This is a case where what we want to take a look at here is what happens when you do a drag and drop. Okay, we see all kinds of things fire, and it doesn't thread lock the system when that occurs, because something in the system, and what we find out later is it's the web API is controlling what happens. So we're taking a look here. We're going to start the drag. We're going to execute the drag. Essentially, we've executed these pieces so that when we drag, there we go. You start to see the X and Y's change. And the X and Y change, and when I let go, the drop has occurred. And if we scroll back through, yeah, there's a lot of these, I'm sorry. Oh, as we scroll back through, yeah, I get all the scroll bar. There we go. Lots of XY changes, and we'll go back up real quick and we'll look at the start of our code. You saw the drag start. And essentially we've attached ourselves to the elements in a way that we can see this activity occur. And this is, again, it's asynchronous activity in the sense that the web APIs for the drag and drop tie into the JavaScript to allow us to execute these functionalities. We're handing off some of that control again in those cases. Event listener is probably a pretty simple one, and it's also kind of tied to that user control. And event listeners, I found out, but to my surprise, are synchronous. They're not asynchronous. So let's take a peek at the code here. And we have a start, and we're grabbing the event listener link button, which is the one we see up there. We're setting up listeners, we're triggering the listeners. In the trigger, we're setting timeouts, we're executing start and end and that kind of stuff. So what should happen, we have the start and the end, and then we have these button clicks that get triggered. So it's simulating a click. Okay, and it's clicking twice up there. So we have to see the handler 1, handler 2 outputs that we bind into there. So if we start the event listeners, you would think you're going to get start the end, the click 1, click 2. Well, since it's synchronous, even with the set, we did the set timeout to kind of isolate it a little bit, but since it's synchronous, those click events occur before the end. It's not an asynchronous activity. Okay, now we'll take a quick look at web workers. I'm looking at my time real quick, make sure we're okay, we're doing good. So web workers, we've all been hearing a lot of cool stuff about web workers. I'm going to show the synchronous code here. And this is one of the first really good use cases I liked, okay? We've all had these percentage bars that we've wanted to run before at some point in time or another. If you've been in the front end field for a while, you've done this and you execute it and something in the background's occurring and it should be updating on the percentage bar and nothing happens. And when I was first looking at web workers, this is one of the first examples I saw where they had put the activity into that web worker. And the web worker, think of it like it's in its own tab. It's got its own thread, separate from your JavaScript engine. So what we do here is in the synchronous version, you look there, we're doing the run sync. The run sync is setting an inline, grabbing the inline progress bar. It's telling it to crunch the numbers inline, and in the crunch for numbers, excuse me, it takes a callback, which is the display percent inline, console logging the percent and setting the value. And as it sets the value, the inline should step forward. But what we actually see when we start this synchronously is we see the timer increase on the console log. And this brings up another case as this steps through, is the console log is outside of JavaScript's thread. Because if that were truly thread locked, console wouldn't have been showing us anything. That was a unique thing I got out of this one, okay? But it did that weird, hey, I jumped to 100% right off the bat, like we would expect. Let's take a look at the asynchronous code where we have a worker, and I've kind of simulated a few things so you can kind of see what's going on. We're going to be passing messages back and forth to the worker. The worker is going to do that count for us on the back end of their side. So we're going to start the async and see what happens. And so every second, the web worker is saying, hey, I've gotten another 10%, another 10%, another 10%, and it's pushing forward because it's on its own thread. We don't thread lock the JavaScript engine, which is really kind of cool. Okay. So the next thing we're going to talk about is load timing, and this is the one that usually crashes if anything does. So let's take a look at the code. And what we're talking about here is when we load the web page, okay? We have a load synchronous and a load asynchronous, and in each of these cases, these are run immediately when the web page loads, okay? The load synchronous grabs first timing and it tries to change it. Okay, change content correctly via code. The load async sets itself with the set timeout 10 seconds later to correctly change content. So that second one that you see on the screen. So this did work correctly. The original content, the reason it couldn't do the first timing was my JavaScript for this is in the head. The load async, if that were at the bottom of the body, that probably would, the load sync, if it were at the bottom body, would have worked okay as well, because that DOM element what happens is the DOM element had not been created within that first 10 seconds for the first, or it had been created after the load sync code ran. In the case of the load async ran after the DOM elements were created. It does take some time to create them. All right, so that's our race condition one. And let's take a look at the set timeout timer. And this is a really cool one where we get to see how the 0 millisecond actually works. So what I've got in here is we set up a delay, we set up repetitions, we set total. If you ever play with this code, be really careful. Total repetitions, I set it 1,000. I think the first time I ran it, I set it to 100,000. And I sat there for 20 minutes waiting for it to finish, or 10 minutes or whatever it was. It's just an inordinately long amount of time because it is going to thread lock the machine as it does it. Because what we're going to do is we're going to iterate. We're going to run multiple set timeouts with a, in this case, 0 millisecond delay to see what the actual delay is. We're going to calculate it. Okay, so I'm going to start this. It's going to take us a little while, okay, to let it run. And realize we're running 1,000 repetitions on a 0 millisecond. And it came back with an average of 4.5. Remember, I told you the default for set timeout is 4. Okay, it does not come back at the exact time that you specified. Okay, and to do this, let's take a look at this. Oops, we're starting it at 10 millisecond to see how long they actually take on average. Are they taking 10 milliseconds, 10.5, 10.3? Well, we'll find out in about 10 seconds. There we go, 10.999. That's about as close to 11 as I've ever seen. Okay, so start timeout doesn't finish when you expect it to, and the base default is 4, regardless of whether you put 0 or not. And depending on the browser, it may be higher. All right, 2 tools that we got out there. Async await is simply a wrapper around promises. Okay, it makes it easier for us to read and understand what's going on with asynchronous code. It cleans up that syntax. So as we look here, we have a start, which has a resolve state defaulted to true. We do a console log start, console log end in there. We have an async await that fires. The async await has a try catch. And it console logs awaiting the async process to finish, which returns a promise, resolve reject, as set timeout that if resolve is set to true, it resolves success, otherwise it resolves failure. And I have this set up so I can resolve it for success and failure and see how this works. And the question becomes, as I always ask, is what order? Start, the end, then or resolve or reject? Do we have start, resolve, reject in the middle? Let's start the resolve and see what happens. In this case, the resolve, the 2 milliseconds after, came after the end. Okay, in this case, because we had the set timeout that put it outside, put it into the event loop and back out again. We'll try the reject and see what happens there. And it failed after 2 milliseconds, exactly the same thing, only on the resolve and reject. Okay. So I'm going to jump right into a quick summary here, but I am with the Leading Edge. We are hiring. Feel free to check us out. We are in as a sponsor for this event today, and yesterday and today. So feel free if there's any thought of looking at something interesting. We've got some good folks working at Leading Edge and some interesting projects. So summary, We examined synchronous and asynchronous code using callbacks. We looked at the debugging, which is now default within Chrome's DevTools. We looked at promise chains. We looked at generator throttling. We looked at user interactions. We looked at event listeners, which we found under synchronous. We looked at web workers, load timeout, or load timing, sorry, and the ES27 async wait. We are doing really good on time. So I'd like to ask at this point, if we've got any questions, if you want to post those into the Slack channel, I can answer those. I don't see anything popping up, so I don't have any huge questions on that. I'll give it a few seconds and then we'll wrap up. Thank you for coming up, guys. Ask her when we're done. There's a question, but it was on track 5. All right, no questions, guys. Cool. I hope you enjoyed the talk. I'm going to mute my mic for now and hang out until Bhaskar tells me we've stopped our channel, okay? Thanks, Luke. Hope you enjoyed it.
Hello, everyone. Welcome to today's talk that is all about Cypress for testing your React Native apps. I'm Janhavi. I'm a software developer at Thunkable. It's a Y Combinator-backed startup, which is based in San Francisco, where I live currently. I'm an avid reader, and you'll always find me with a book in my free time. Also, I love traveling, especially to try out new cuisines from various places. So before we move ahead, let's get a quick look at the agenda for today. I'll give a brief introduction to the need for Cypress in the current environment. Then what exactly is Cypress and what makes it different than the current available tools? After that, we'll learn about the Cypress ecosystem, and I will show how to install Cypress and a quick demo of adding Cypress tests to a real-life application. We'll also see how we can write component tests in React and Vue and finish up with some additional comments about Cypress. So in a single line, Cypress is an end-to-end testing framework that provides fast, easy, and reliable testing for anything that runs in a browser. So if we look at a rough development timeline, there are these steps we follow. So the first three being planning, development, and deploying. And after that, we have staging and QA and production. Generally, all the end-to-end tests are performed in the staging and production steps. In the staging, the QA does the end-to-end testing, and in production, the users do it for us and find bugs. The Cypress team recognized that the cost of fixing the bugs, and here the cost means not only the money, but the additional work and time required. So the cost increases as we go ahead in the timeline from planning to production, wherein identifying bugs in the planning stage is the best case scenario, while in the production, of course, it's the worst case. So why not we perform end-to-end tests in the development phase itself? If it is done properly, this would save the additional efforts and also save the development time. So this was what the motivation was behind developing Cypress. So what exactly is Cypress? Cypress provides a complete end-to-end testing experience for your web applications. And as you might know, most end-to-end testing tools are Selenium-based, where they run outside the browser and they all face the same problems. Cypress has a new architecture wherein it does not require executing remote commands to your network, but it runs in the same run loop as your application. Cypress tests are only written in JavaScript. So basically, the test code is executed in the browser itself, even if you can compile down to JavaScript from any language. The Cypress architecture is made to handle modern JavaScript frameworks. So you can use Cypress with any framework like React, Angular, Vue, Elm, etc. And we will see examples in the further slides of how we can do that. As end-to-end testing is possible while you code your application, it makes test-driven development easier for developers and also for the QA. So it is developer and QA friendly. Also, Cypress is free and it's open source. So there are people all over the world contributing to that code, to the Cypress code base. And you can give it a try right now for your project without investing anything. And Cypress has been built so that testing and development happen simultaneously. The end result is that you will have developed more, your code will be better, and it will be completely tested. They have an additional service called Dashboard Service, in which they provide, we can parallelize our application, and also they provide automated load balancing. So what things make Cypress different than the already existing tools we have for testing? Cypress takes snapshots as your tests run. So simply hovering over the commands in the command log, we can see exactly what happened at each step. So it's a total user interface, which we can guide through and also look at all the commands individually. And also it captures videos and screenshots when the tests fail. And we'll see all this in the demo, so that will be more clear. Cypress automatically reloads whenever you make changes to the tests. So you can see commands execute in real time in your app while you develop it. And that's why it's faster. Cypress provided ways to debug directly from external tools like Chrome DevTools, which generally we are familiar with. And this makes the process super fast. We don't have to learn anything new. If you have experience in writing tests, you might be familiar with adding extra wait times or sleeps to your tests. So with Cypress, this is done automatically using its assertions and commands, and it saves a lot of development time. If there is any failure in your tests, Cypress automatically captures the screenshots, and also it records a video of the entire test suite while running the tests. Also, Cypress ultimately controls the entire automation process from top to bottom. So it uses a Node.js backend, and it has a GUI interface. So this puts it in a unique position of being able to understand everything happening in and outside of the browser. So this means Cypress is capable of delivering more consistent results than any other testing tool currently available. So let's look at the Cypress ecosystem. It is majorly made up of two entities. It consists of a free open source locally installed test runner. First, Cypress helps you set up and start writing tests every day while you build your application locally. So that's where the test runner comes in. And Cypress supports test-driven development at its best using this test runner. Later, the second entity is the dashboard service. So after building up a suite of tests and integrating Cypress with your CI provider, the dashboard service can record your test runs. So from the dashboard, you can manage users, integrate with GitHub, Bitbucket, GitLab, Slack, and even Jira. So it also provides analytics to offer insights into your test metrics. So it's all visually pleasing and also helpful for us. With Cypress, you can run tests with Firefox, Brave, and Chrome family browsers, including Edge and Electron. So as long as you don't use Internet Explorer, you have nothing to worry about. Cypress is a desktop application that is installed on your computer, and it supports Mac, Linux, and Windows. Also, if you use npm install to install Cypress, you will need nodes 12 or 14 and above. And to install Cypress via npm, you simply need to run this command in your app directory. This will install Cypress locally as a dependency. And you might need to run npm init before this to ensure Cypress is installed in the correct directory. Also, if you use yarn, you just have to run this command and Cypress will be ready for you to use. So it's as simple as that, as simple as running these two commands. So to show how Cypress works in a real life example, I'll be giving a short demo. But before we move ahead with the demo, let's see the folder structure of the Cypress step. So right now, you have run the npm or yarn commands to install Cypress in your project. Once you do that, Cypress automatically creates a folder structure as shown here. If you see, fixtures are used to store test data, which can be used throughout the tests in your application. Usually the data is stored in the JSON format. Integration folder includes all the test files. So the test files may be written in JavaScript or JSX or Coffee. Usually the preferred extension is .js, and the test file name format is testname.spec.js. Also, we can keep the structure clean by assigning the tests into relevant folders. So here we have two folders, getting started and advanced examples. And the todo.spec.js is the test file. The plugins folder includes index.js file. So this file will be automatically imported every time before the execution of every test file. So plugins enable you to tap into, modify, or extend the internal behavior of Cypress. The support folder contains the index.js and the command.js files. The index.js file is run before every single test file. This is a great place to put global configuration and behavior that modifies Cypress. In commands.js, you can write various custom commands or overwrite existing commands. The changes here will be available to all your test files. Also, Cypress records a video for each spec file when running tests during the Cypress run. And all these videos are stored in the video folder. There's also a screenshots folder which collects screenshots automatically when a test fails. We currently don't see it here because no test has failed yet. We'll see how it works in the demo. Cypress.json is used to save different Cypress-related configurations, for example, base URL, timeouts, etc. And the default behavior of Cypress can be modified by supplying the configuration options in this file. Now, you might have a question by what to do if I'm using TypeScript. So Cypress starts off with everything being in a JavaScript file. If you want to develop in TypeScript, you can rename the test files with TypeScript extension. But only doing that can cause some problems since VS Code can think that it is Muka or Jasmine and doesn't know what Cypress is or what CY is. So to fix that, we can add a tsconfig.json file inside the Cypress directory. The file tells that these are the compiler options and the only types that exist are TypeScript, and we include all the TypeScript files. Adding this improves the developer experience and you can use TypeScript in your code. So let's do a quick demo. In this demo, I'll be showing the various features of Cypress. Of course, to get to know it better, it would be the best if you give it a try yourself and consider this demo as a brief introduction to Cypress. I'll be showing a video because we don't want to waste any time if there are some network issues or anything with the demo. So I hope you can see the VS Code. And let's start with it. So this is how the code structure looks like after installing Cypress. We have already seen the folder structure for it, and we know that the test files are under integration. So let's open that. Here we have a todo.spec.js, which is a test file for a to-do app. We'll go over the code later on and now just see how we can run this test. So what we'll do is in our terminal, we'll run the command for opening Cypress from the root folder. So we'll just type /root modules bin and Cypress open. So what this does is it will open a new window for us. Basically, it lists all tests we have in our code base. So we can run them all together or we can run them file by file. Also, you can see the drop down here, which shows the available browsers in my machine. So that Firefox and Chrome and Electron by default. So let's go ahead with Chrome for now. And yeah, you can run all the files together, or you can just double click on a single file to get it to run individually. So let's first run them all together to get a glimpse of how Cypress runs the test. So this is a test runner of Cypress. As you can see, it is running all the tests one by one. So basically what you see on the right-hand side, which is constantly changing, is the app preview. Cypress lets us see our app while the test commands execute in real time. So it looks quite pleasing, if you ask me. And it's super fast. I'll be explaining every component of this window one by one once the test finish. So the green tick marks you can see on the left-hand side are basically test passing. If a test fails, it will just show a red cross. We'll also see an error scenario and how the test fails and how we can debug it. Cool. So now that all the tests have run and it looks like all the tests have passed, let's go at the beginning of the section. Here we can see the test status menu. It shows us how many tests passed or failed and how much time the test took to run. Below that, we have the command log. So every command logs as it executes. We can hover over them to highlight the affected element. Or you can click to log more info to the console. So this is the URL preview. The URL of the app updates as you test. So you have more visibility on the testing routes. Also, you can test responsive layouts in Cypress by setting your app's viewport size so that it goes to a mobile device or any other layout window you want. Now, let's look at our first test. So clicking on the first test, we'll see that we have a before each block. So basically, this section runs before every test. And clicking on that will give us the DOM exactly how it was at that amount of time. So it's like a time travel to that place and that URL we have. The next is a test body. So we have a get command, which will give us the class with to-do list and all the li elements under it. And it has highlighted all the li elements. Then we assert saying that the li elements should have a length of 2. And that has passed because yes, they do. Then we will get the first element. So the pay electric bill has highlighted, and I have added the assertion that the li element should have the text pay electric bill. And the last one, last element has the assertion that it should have the text walk the dog. So clicking on each of them will give us the highlighted element in the DOM. So this was our first test. Now let's look at the code and the test side by side. So this is our spec file. So all the tests can be written here. And this is our test, displays two to-do items by default, which we can see in the test runner too. Now let's say we only want to run this test and not all other tests. So we'll just add the only keyword. And once we save it, the test runner reruns and we can see that only one test has run. So it is that fast. It's like just saving would run your test. And let's go ahead and let's see if we can get an error in our code, in our test. So instead of pay electric bill, let's say pay internet bill and run it. As you can see, the test is running and it has showed us the error. Let's maximize this window. And so the before each block was executed, then the assertion said that we should have 2 li elements. But when it goes to the first element, and the assertion says that expected is pay internet bill, but it's showing pay electric bill. And it shows us the error. So this is how the error looks in Cypress. And also, being developers, we are very curious about how this all looks in the dev tools. So Cypress has provided that too. If you inspect and open that tool, and you can see that every command has a key value pair. So if you click on that command in the Cypress test runner, it opens the text-rated version in the console. So you can see the command, subject, message, And also clicking on this link will give you the exact place where the test failed. So debugging is a hell lot of easier with Cypress, and it just takes clicking on a particular link or particular file. So let's close this for now. Let's stop it and let's go to our code again. So there's another way to see our Cypress commands run. Cypress test run is by Cypress run. So if you don't want the user interface, you just want this to run on the terminal, you can just do Cypress run. You can see the Cypress version is 8.3.0, the browser is Electron, and it has all, and it is running the test one by one. So our first test should ideally fail because we do not have the proper text in the li element. So it shows that this test failed and the expected was pay internet bill, but the actual was pay electric bill. So it's visually pleasing and it shows everything properly in their proper pattern. So it shows how many tests failed, how many passed, and the screenshots, the videos. And yeah, so Cypress also has a very unique feature of capturing the screenshot of when the test fails. So you can see the screenshot and you can share it with anyone, or you can help others to debug, ask help from others to debug. And also you can share the videos to know what exactly happened and how it happened. And all these are stored in the folder structure. So again and again, if you want to run Cypress tests, you need to type this command, node modules bin Cypress open. So instead of that, we can create a shortcut in our scripts file. So in our package.json and add script over there. So we can just add Cypress open, and whenever we call Cypress open, whenever we call Cypress open, it should run Cypress open. So let's delete this and we'll see how it works. So we'll do npm run Cypress open. And it will open the window for us as it did previously. So you can do anything you want in whatever shortcuts or whatever text you want, and it will run the command. So yeah, we'll be looking at all these commands and all these stuff in a proper way in the next slides. So this is the end of the demo, and let's move back to our slide. So we saw that in literally seconds, Cypress does what it would take an individual several minutes to go through the process. And also it's a boring and repetitive task, which can affect the quality of the application. So Cypress, I feel, is faster and also it saves us a lot of work. So this is a sample Cypress test. So we saw in the demo, the test file, right? Then how each component in the test file is arranged. We'll look into that and we'll say the meaning. So Cypress believes in getting more done with less typing. It follows a chaining syntax and similar to jQuery for query elements. In fact, Cypress leverages jQuery's powerful selector engine to help test familiar and readable for modern web developers. So you can see here, the describe keyword is simply a way to group our tests. It takes two arguments. The first is the name of the test group, and the second is the callback function. And we use the it keyword for an individual test case. It takes two arguments again, a string explaining what the test should do, and a callback function, which contains our actual test. So let's see what this Cypress code would read as. So in here, we tell Cypress to visit the page at /post/new, find the input with the class post title. And in that input, we type my first post. Then we find the input element with class post body. and type hello world into it. We find the element containing the text submit and we click on it. So basically it's a button. Then we grab the browser URL and ensure it includes /post/my first post. And we find the h1 tag and ensure it contains the text my first post. So this is as simple as that. It's like talking and you'll understand what the Cypress code is doing. So there are many more methods and selectors provided by Cypress to support all your testing requirements. And even though Cypress is open source, it is very well documented. As you can see, this is a snapshot from their documentation. You can find many courses, sample applications, workshops on if you go to Cypress.io. I would recommend going through them by choosing the framework you use and trying out the samples. They are very helpful in understanding the nitty-gritties of various applications you can think of or you can use in your existing project. So currently, very less tools are available for performing end-to-end tests on React Native apps. And performing end-to-end testing of React Native apps has been less than an ideal scenario until now. The tooling for E2E testing on the web is very simple. And thanks to Expo for Web, you can now use Cypress to easily perform end-to-end testing of your React Native app in the browser. So React Native apps are known to run on your mobile devices, right? And as we saw in the demo, we can make Cypress run tests on responsive layouts. So if you want to test your React Native app on a mobile device, run the test on a mobile device, you can simply change the layout size on the task runner and it would be good to go. Also, Cypress can access the elements from the React Native components we have in our project using class names or target elements based on the CSS attributes. But the drawback of using the class names is that the same names are used in your CSS as well as JS, which can lead to changes, which there can be some changes in those files. So according to the Cypress team, the best practice is to use data attributes. They provide context to your selectors and isolate them from your CSS or JavaScript changes. Oftentimes, users run into problems targeting their elements because application may use dynamic classes or IDs that change, or selectors break from development changes and to CSS styles or JS behavior. So do add the data attributes in your code to make it easier to target elements in Cypress tests. Next, let's look at how we can write component tests based on individual frameworks. So if you are testing a React component, you will need to install Cypress tools for React. Once installed, you need to configure how Cypress will locate component spec files. So after that, we create a spec file next to the component file that is to be tested. So right now, button component is to be tested. So we'll create a spec file in the same hierarchy as the button component. And the spec file will consist of this code. As you can see, a Cypress component test contains a mount function and assertions about the button component it has rendered. So a test may interact with the component as a user would, and it will use the Cypress API commands like click, type, etc., which we already saw in the normal Cypress test. So nothing is different. The only thing which is different is installing and then using the mount function. Otherwise, all the Cypress commands and all the structure, everything is the same. And we have a similar structure for Vue, wherein we install the dependencies and use the mount function for the hello world component. So you now know that Cypress works from within the browser. So you might be wondering, how does it support HTTPS? So Cypress does some pretty interesting things under the hood to make testing HTTPS sites work. It enables you to control and stub at the network level. Therefore, Cypress must assign and manage browser certificates to be able to modify the traffic in real time. Also, Cypress test can be run in continuous integration, and we can configure Cypress in various CI providers like Circle CI, GitHub Actions, GitLab CI, and AWS Code Build. Cypress can also be used in Angular apps and can create reliable end-to-end tests for them. While Protractor has been a popular end-to-end testing tool for Angular and AngularJS apps, it is no longer included in new Angular projects. So Cypress also provides a migration guide to help transition from Protractor to Cypress. All these things are already mentioned in the documentation, so you can go there and you can follow the steps and you will get what you want when you want to migrate from Protractor to Cypress. Yeah, so there's a lot to Cypress that can be covered in such a short time. So I would recommend going through docs, and I guarantee that there will be something for everyone's use case. And I thank you so much, and I hope you get motivated to give Cypress a go. And feel free to message your questions on the Slack channel here. And also you can message me on Twitter. Here's my Twitter handle. Thank you all for listening. Have a great day ahead.